Hello and welcome to Exercise 11, Chapter 4, Dynamic Dating Fetching. The objective in this exercise is to learn to fetch and combine data from multiple APIs using promises, delays, with visual feedback, and reactive state handling. A promise is a JavaScript object that represents the eventual completion or failure of an asynchronous operation and its resulting value. What you will learn: 1. Using $state to manage reactive promises. 2. Combining promises with promise.all for multiple fetches. 3. Utilizing #await blocks for handling promise states in the UI. 4. Adding delays to simulate real-world API latency. 5. Handling errors gracefully for reliable user feedback. Okay, let's see this in action. Click the blue arrow next to for_11 Dynamic Data Fetcher. You see a title, subtitles for post data, user data, and combined data. You might note that the user data appears first and a few seconds later the post data and combined data appears simultaneously. If you didn't see that, click another exercise and click back on Dynamic Data Fetcher to confirm. Okay, that's all there is to it. Now let's look at the code. Open up x11_dynamicfetcher.svelte. We import that fetchUtils utility that we created as a reusable fetch function in a previous exercise. Set state for the two URLs. We set up our first promise, post promise, which uses the imported fetch data to fetch data from the post URL. So what it's doing here is setting up a network request, which it delays 5 seconds. Remember, a promise is a JavaScript object that represents the eventual completion or failure of an asynchronous operation and its resulting value. A promise has 3 states. 1. Pending, the initial state before the operation completes or fails. 2. Fulfilled, i.e. completed successfully, or 3. Rejected, i.e. the operation failed. So the dot then represents the fulfilled or success, with post being the data fetched. The rejected is the catch. And the pending, which is the initial state, well, we'll see that in the markup shortly. The reason for the 5-second delay here is twofold. First, in case you have a fast computer, internet connection, you might not be able to see the sequence these load in as it happens fast. And secondly, I want the post to delay longer than the user to show that even though the post fires first, in real life, you can predict which promise will be resolved first. The purpose here is just to get those promises on their way, in parallel, sort of, and then have a combined promise, waiting on these 2 promises. Okay, so the next promise is for the user data. I gave this a 2-second delay, so you can see when it runs it will pop up first and then the post data will show up 3 seconds after. And next, we use the promise.all, which will wait for both post promise and user promise to resolve, or for one to reject. If successful, then combines the result into one object. Function delay uses promise to create a delay. No cleanup function needed here as set timeout is self-contained. It resolves a promise and doesn't persist beyond its execution, so no memory leak. That's the script. Now in the markup we have 3 code blocks, one for the post data, one for the user data, and one for the combined data. We use the #await post promise syntax here to show the different states of the promise: pending, fulfilled, and rejected. Initially it's always pending, and I mentioned above that you will see this in the markup. And here it is: while we await we display loading. Dot then is success, fulfilled, so then post means the promise has fulfilled and the result post is available. So we display the post properties, chit and body. Catch is the error. Similarly for the user data, so I won't repeat all that. And lastly we come to the combined data, and again this is very similar, so I won't repeat. So that's the code. Now in case you are thinking, well, why would I need to use something like this? That's a good thought. A possible use case for such is fetching data for a dashboard, where for example you may need user profile data and user activity data being fetched from different tables, and promise.all will fetch both datasets in parallel for efficiency, and #await allows you to dynamically update the UI. Okay, that's a wrap for exercise 11. I think I have a couple more exercises before we get into the challenges. If you find any of these exercises useful, please like. If you want to know when the next videos are arriving, please subscribe. If you have any issues, suggestions, requests, drop a comment or email. Thank you. See you in the next video for the next exercise.